Test. Test audio. Test audio. Cool. I think we're good to go. So, I have basically this little bracket design that music got way too loud. Okay, so there is a rearview mirror on a golf cart that I don't have any pictures of because I'm not smart to take pictures of them. I think is my camera. No, it's upright. Okay, I just can't look at things. And this bracket bolts into the ceiling. You can imagine a plane sort of roughly where the top plane is here. I'll make this a little bit bigger. It bolts into the ceiling like this. And then on this plane, on the right plane, there is a sort of slotted piece that comes down that I don't have modeled just because it seems super important. And then the mirror bolts into that. And this little guy up here, as you can tell by the way that it's got just 2 fasteners plugged into it, that's all that it's got. And then it's an inch away over to the mounting surface, so you get some really big moments applied to this bracket, and since this is all that's holding it, things tend to get kind of wobbly. So, who's messaging me? Why would anyone do such a thing? Oh, perfect. I was... So, all this blustering about not having a picture... Yeah, hang on, let me go grab this. So I just sent a message to a family friend has this little bracket, and it's bolted up in here. These two little, for some reason, flathead Phillips screws bolt into plastic, and then we've got this guy, and it's got a washer in the back, and these are just 2 regular. I think this is 1/4 20. So you know, fairly nominal fastener size seems alright to me. But this is actually super handy because now I can plan kind of where I want extra fasteners to go. I think what I'm going to do is I'm going to stick with these slots back here. Well, we can switch back to... there are slots that are kind of hard to see in the picture, but I have them on my original drawing, which... Check this out. I made a drawing. It's kind of rubbish, but it's enough to figure out what the part looks like. And we're going to keep most of this structure, but just add a whole bunch of extra, like, plastic flat area. So you can drill a couple more holes and have this thing be really secure. I think I'm going to have to probably keep some of the slotted length, maybe not all of it, but certainly some of it, or probably most, so that there's some adjustability in where the mirror sits. And I'll just figure out and probably make those slots the same over here and over here, so that we have a nice big flat area to keep this thing stable and square. So, with that said, let's hop to it. You know what? This music just isn't... I love this song, but it's really not great to model to, so... Oh, I'm getting a call. Hey, Mike.
Hey, Clark, how you doing?
Good. I'm actually streaming right now, so if you want, you can watch. It's fine, though. It'll be recorded for later, so... Hi, stream. This is me calling Mike, the guy that I'm designing the plane for. Yeah. Oh, don't worry about it. I got all the information I needed to know, which is like how big that nut is on the backside, so I know how much room I had to design around. That's what I needed to know. All right, sounds good. I will show it when I get it. Yep, of course. Bye. Yeah. Mike's awesome, great family friends, wonderful people, so. And music. I broke music. Okay, Billy and the Clonosaurus by You Break You Buy. The previous one was Applique by Parker Projection, both very good bands. And now I gotta go find the next picture. Awesome. Okay, so here's... Let me just pull up Paint.net again. Whoops, hang on. So now you can see the backside. It's got this thing which is kind of a carriage bolt, which is a little weird. It's probably going to change. I'm probably going to change that. 1/4 is fine, but having a carriage bolt with a nut on the back is just really weird. And then this is just a big slotted piece that goes down to hold the mirror. And I could hypothetically design something to take up all this and do the whole thing all at once, but doesn't really need it. And I'd rather design just the flat plate up here because it'll be a lot easier to print. So, critical dimensions to pull off. We'll just open up the original part file so we can spin around a little easier. This thing is roughly 3/4 of an inch across, which, and this bit up here has to be 0.075, and we have to have a 1/4-20 clearance to get a wrench around a 1/4-20 nut over here. And on the back side, if we're looking at that picture again, do I really have 2 windows open? No, okay, that's just, oh, that's nice. Paint.net tabs them. I didn't know it did that. But we've got this nut, so we have to have clearance for that fastener and the ability to get a wrench in there. So, yeah. Okay, so big flat plate, need roughly 5/8 of an inch travel on these big slots. Let's go do that. Straight across top plane. I'm gonna think about how I want to. Oh, you know what? This is going to be a mirrored part, so I can save some time just starting with that assumption. Go like this. Kind of out and around. Up. Roughly the same angle. Not really the same. That's fine. Oops. Come on. And I probably didn't get all these tangents, so... Alright. Did I remember to do this in IPS? I did, thank goodness. Make those concentric. Whoop, that's all jacked up. Where is the... Oh, hang on. Not sure I want to make that concentric with that, because then it limits my ability to sort of go over its head. I do want all these fillets to be the same, though. Actually, I'd rather... This one is important because this one has to be sort of define another feature, but these guys, I can just merge them together. Just make sure that they're well clear. Whoop, that's all kinds of messed up. You get out of there. Come on. Play nice. Man, that's just all kinds of messed up. You know, I think I actually do want... Yeah. Let's keep an arc over here. Make that concentric. Make that tangent. Trim off that little edge there. There we go. That looks about right. The more that I look at this, the more that I think it's probably alright to leave this concentric. So I'm just going to do that. Oops. Make that tangent over there. Pick this edge up. Make that right there. So, now I got to think about what other dimensions I have to pull off this. So, oops. These slots are 195 across. Yep, matches my drawing. And they left less than 1/10 of an inch of meat on there, which I'm not really happy with. So, this is definitely going to get a little bit larger. But in the meantime, we can make these two slots equal. 0.5. The reason it does that great big... Well, here, I can even show it again. 0.04. Oh, I guess not. The reason it does that great big, it shows all the extra blue over here, is because it'll scale the part down to the origin to match the dimension that you first placed. So it's really important when you place your first dimensions to place a numerical one instead of like an angular one, because then the next time when you place your next dimension, if the scale's off, things will just get all out of whack. It's no fun, having done it quite a lot. What? Oh, you know what? I didn't dimension. So I'm gonna have to pull this from my model, but I didn't really dimension the distance from center lines on these two slots. So 3/8. That's probably 0.375, 3/8 of an inch, if I had to guess. So we're just gonna do that. Oops. If I dimension from this point, I can go across the center line. Otherwise, dimensioning center line to center line, you can't have one be the center line, because then you don't really know where you're which one you're defining as the true center line to use for mirroring, but defining this way works. So. And I just realized I don't want that line there. Well, yeah, I don't want that line there. Oh, that should be tangent. Should be tangent. That's looking kind of silly, but doing okay. Let's do it this way. Let's say I want 0.1875 of meat around that. That should give me... It's really goofy, but... .875. Oh, I didn't make these all the same radius. That'll do it. Well, that's all kinds of messed up. Oh, hang on. Did this one decide to be... Oh, that parallel is what's giving me trouble. We can get rid of that parallel and move this around a little more. Especially because this absolutely needs to be on the interior here. 0.75 across, so that we can have our flat plate to mount to. So, get these dimensions out of the way. And trim. Oops, hang on. Tangent. Tangent. Oops. Get rid of that tangent constraint. Really need to give these guys a little more, so 675 is pretty close to what it was. 665, yeah, that's 5/8. Good enough for government work. That really does not want to play nice, does it? What if we make this real small for a sec? Ah, there we go. These two are tangent with each other for some reason. That's going to cause issues, because then if they're tangent and they're both tangent to this line in the middle, then that line is 0 length, so that doesn't work. SolidWorks gets really pissy if you do things with 0 length lines. There we go. Yeah, that's kind of what I'm looking for, is I want to be able to put this guy wherever I want him. Make this a little bit bigger, say maybe 1/4 inch. I'm on the fence about that internal corner there. Where do I want these? Well, we can at least define sort of the length across, say 3/4 of an inch is probably fine. Some sort of downwards offset, so... Maybe 0.375 plus 0.065? What does that get me? 0.438 seems alright. And this drawing is a proper mess, but not really a whole bunch to be done about that. Well, I can sort it out a little bit. Okay, so that leaves me with a nice face in here. And this guy, I've got all my spacings right and nice. There's only a few things that are really weird, which is honestly a lot better than I usually do. Maybe I can bring this guy down here. Yeah, that's good enough. It's visible, it's clear, so. Whoops, hang on. I can't extrude that. Oops. Top plane, there we go, okay. So this guy, and then, let's see, select chain, okay, and then pick this guy. Hopefully, yes! Mirror just works. You'll love to see it. I wonder what that line's doing. Nothing, apparently. And now I can see that that's a little bit too large, so I can shrink it. 0.125 plus 0.03125. That seems alright. 0.15625. Shrink everything down a little bit. Alright. We're getting there. We're getting somewhere. I don't know if it's where we want to be yet, but we'll find out. Ooh, this has to be a multiple of 0.2 millimeters if I want smooth surfaces on the top, so... 0.2 millimeters times 10, it's 80 thou, roughly. That should be alright, I think. It's not going to be perfect, but it'll be pretty close. Oh, you know what would be really cool? If when this swept out, it came out perpendicular to this. These guys would have to be further out for it, but I think that's worthwhile. Oops. Make that 1 inch. These guys can come up kind of like this. So I'm going to add a quick... We can do an offset, figure out how thick we want this to be, so probably 0.75, 0.075. Or no, let's do it the same thickness as the part, so 0.2, I think I said 20, so that'd be 4 millimeters. That looks a little thick. 2 millimeters? That looks about right. Oh, these do all have to be construction though. I'm dumb. Yeah, okay, it's perpendicular. Construction, so it doesn't mess with the rest of my geometry. Trying to figure out how I want to constrain that to like a relative middle. And I think this is probably the weirdest possible way to do it, but if I make this tangent to this, I make this guy tangent to this, then we're going to end up somewhere in the middle if we make these two equal. Yeah. Does that give me like a nice round number in here? It does not. That means that we're on the right path. Okay. Well, that's handy, because that lets me put a nice big fat rib out to the edge there, which is good. Exit sketch and rebuild anyway. Nope. Now something doesn't exist. Well, what are you complaining about contours? Oh, hang on. This one might not be construction. Yeah, there we go. Okay. That line in there, because it wasn't construction, it was no longer a single closed sketch. It was an open sketch because that one became an extra. It basically became an extra edge, and SOLIDWORKS doesn't know what to do with that if you don't have just a single continuous chain. If you've got branches, it throws its hands up in the air and says, hey, this is no longer what I thought I had, so it doesn't do anything. So, we now have the expanded part of this bit. And actually, hang on. Insert. Components. Actually, hang on. Insert components. Not them. Oh, need to save it first. New brackets. Oops. Insert. New bracket. And we're going to call this one. I'm going to make this one an envelope so it'll show up as blue and not really real, which is fine. Front, right, mate. Top plane. Looks good to me. Right plane to front plane. That should line everything up. You said envelope. Why is it? There we go. Okay. That's what I was expecting. So now we have something to compare to, and it looks like we actually have these fasteners a little bit. Those slots are in the wrong spot. And I think something's not working, because normally when you click on the feature, it'll show you the whole sketch. Is it rapid sketch? I don't remember. Rebuild, turn it on and off, check, save, check part. I don't know. Sometimes it works, sometimes it doesn't. We can actually check what that dimension is, though, because I'm reasonably confident on my distance between these 2 points. So we call this... Oh, it's in point-to-point mode. That's why it was giving me a weird dimension. So minimum distance between these two, 0.3 inches. That seems pretty reasonable. So just quick add that in. Oops. 0.3. Hang on, that's done something weird, hasn't it? 0.3. 1.5. No, okay, that's pretty reasonable. That does what I expect it to. It moves everything up relative, so I can actually probably increase this a little too. 0.5, 0.75? Will it even... Oh, it will handle that. Nice. It's nice when something works kind of unexpectedly. It is wrong in translation from Jewish. I don't know what you're talking about. Is it translating me into French or something? Okay. What's that word? Okay, yeah. So now I need to add the... Come back over. Oh, I already am in the part. I have this sketch. I have these sort of bosses I can use. I almost want that to be thicker, honestly. What happens if I make that like 0.125? 0.1875? Wow, make that really thick and it just kind of... Oh, slots are translationally in the wrong place. Yes, they were. But I have now fixed that, and they're pretty close. Within a few thou, I think. I'm not really too worried about it. We may have to get more fasteners as well. I'm going to chamfer these so that the flatheads sit a little better. And then I'm going to forget what I was talking about. Yeah, so goal is design this thing, but stiffer. And I have some pictures up that I got from Mike. It's easiest place to see what this guy looks like is from right here, and I can switch the view to be... Hang on. Whoops. So we've got this sort of... I've been calling this part the foot because it's the part that is a foot, it sits against something, and I think I was calling this the leg, but it's shorter. Don't think about that too hard. But this bit is just, it's super floppy, so. Do I have the assembly open? I do. So we'll hide this bracket for a sec. And these two fasteners are the only thing holding this bracket on, and by extension, as you can see in the image, the only thing holding this mirror on is, well, these two fasteners at this end and two more at the other end, which is just really subpar and a weird way to design this. I mean, it's cheap. That much makes sense. But it doesn't hold very well, so I think I'll probably just expect to replace these quarter 20 fasteners and maybe make this a little thicker because we're working with plastic. So, well, if you tighten it, it's just going to crush it, and can't very well have that. All right, so now I need extruded glass base. Let's come up here and work from this sketch. Convert these guys. Oops, don't offset, please convert. Okay. Now I can hide all that sketch stuff. Select all this and mirror. And now it'll always be based on the stuff that I sketched earlier. Just need to add a few more defining lines to give myself some exterior profiling here. Oops. Go the other direction because we want 0.75 for the maximum height down from the top. 0.75. I just realized that could be really hard to get a wrench onto, so I'm going to have to rethink this a little. Well... Needless geometry optimization, where would I be without it? I'm going to make a path length dimension that is the length of these guys. Path length. And it'll be driven, which is just fine. That's D1 sketch 2. And now I can do a sketch on the front plane. If this works, I'm going to be more than a little surprised. Whoops. I want it down on this one because I'm trying to cut off the bottom side, so equals D1 at sketch 2. Why is it not defined anymore? Oh, I see. Horizontal to that one, please. Okay. This is going to look really weird, and I have no idea if it's going to work. Wrap on these two. Whoops, I need analytical so I can get all that good stuff. Cut, and let's go 0.125. Nope, that looks all kinds of jacked up. Alright. No trickiness. I think probably the best course of action here is just something nice and simple, so. Well. Okay, no, simple. Oh, now equations is complaining again. Through all. Okay, that looks pretty reasonable. I can always fill at that and it'll come out nice. Gotta fix my equations because now stuff doesn't exist. You know what? I think we'll be able to get a wrench onto that. I'm not really worried about it. 3/4 of an inch. Quarter 20 hex nut clearance. Hey, look! SIA box wrench clearance chart. My favorite kind. Okay, so A is our clearance radius, it looks like. Wrench size. Wow, that's super not helpful. Quarter 20 hex nut size. Quarter 20 thickness. Wrench size is 7/16, which is going to be a little more than a half. It's going to be like 0.565. Okay, wrench size is... yeah. That would be 5/8, which is... no, 7/16 is less than a half, so we're actually 4/3/8. So A is 4 is the radius, so we have to... this length has to be 0.8 is what it has to be. Which I can go back here and I can say 0.8 and nothing really changes for some reason. Why? Oh, because that's defined by being perpendicular to this. That's fine. We'll definitely have enough clearance on this side to get a box wrench around it, which is all I'm really worried about. So, let's mirror this trim over here across the right plane. Just get that out of the way. Yeah, I had a brain fart there. I've been working mostly on metric this week on modeling some fasteners for our part library, and all my brain 100% thinking in metric right now. Fillets wouldn't be a part of mine if I didn't add just a grossly unnecessary number of fillets. Select tangent. And select tangent. That looks good to me. We are tall enough, right? 0.75. So let's do a hole wizard. This part's going to end up being a little bit thicker than the original one, so we will need new fasteners. We will need new quarter 20 fasteners there, but that's fine. Yeah, in metric 7 is larger than 8. How did you know? I mean, maybe we're working in heptal, I guess, would be a base 7 system, and so 8 just isn't a number. So that's what I'm going with. Positions, backside of this guy. Whoops. Hang on. Down from this edge, we are... I think 0.375 is safe. That could be kind of tight. Not through all, but just up to next, please. Oh, wait a minute. It was taller. It was 0.865. It's like, huh, that looks like it doesn't have enough clearance. I wonder why. 0.865. I'm going to do 0.875. Not minimum, but center to center distance is 0.32. So it'll be a little tight, but if you put a washer in there, that'll space it up enough to be clear of that. And I could bring this down to maybe 80 thou instead. Not sure I like those meeting up square. Let's tweak that. Oops. And for normal. Oops. It really wants to be parallel with that, which is quite annoying. This time next year. Alt A. And parallel. Construction. Tangent. Just slowly massaging everything into place. Let's call this 2.5. It's probably fine. Ooh, actually, if I define this as parallel to this, then these won't be the same, but I want them to be the same. So instead of defining it as parallel, we're going to define those two arcs as having the same radius. Radius 0.25, radius 0.25. Cool. Now I can just chamfer the hell out of it. Yeah. Cool. Alright, chamfer time. Let's see, so I want a distance set back. Start with, say, 20 thou. $40,000? Seems okay. All together better now. You know, I almost think I like it better without chamfers around the edge on this one. Just the fillets are good enough. Yeah, that looks pretty good. Let's go take a look at it in situ. We hide this original bracket. I have these ones spaced up a little bit, but we can change that since those are just distance mates. Make that, say, 20 thou. Oops. And make that 20 thou. Yeah, so those should sit in there nicely now. And it'll be a little bit thicker. And it'll be plastic, which will be a little bit funky, but this extra meat up here should give it what it needs to be a little bit less floppy. Do I want... Here's what I'm thinking, is maybe I should add, like, a couple of washers on the outside here to move this inboard and put these fasteners a little closer to the middle and move this face closer to the center of where the 4 fasteners are going to be. I don't know, man. I think I do want a little more meat on the outside, so we'll fix that. 0.1875. Oh, I still have that pointless path length dimension in there that's not being used anymore. You can get rid of that. Okay, if I did chamfer it, what would it look like? Come on, give me a chamfer, please. Say, just 20 thou. Okay, that does make it look snazzier. I'm gonna have to leave that. How big is 20 thou? It's like 20 thou is half a mil, so 0.5 mil, so it'd be roughly 2 layers, 2.5 layers. Let's do maybe 0.3. Come on. Pick the dimension, please. Thank you. 0.03. Yeah, that looks good. Oh, you know what? Hang on. Quarter 20. carriage bolt dimensions. Okay, so we've got O, which is the square width for a quarter 20, is max 260 and min 245. So we can just punch a hole in the back here that's exactly the right size for the carriage bolt square. And then we can use the same fasteners, and we don't have to use that extra washer piece, and it'll just bolt right into place. Which is extremely cool, now that I've said it out loud. Where's this fillet coming from? Oh, that one's... hang on. You should go down there. So it can work entirely before the fillets. Extruded cut. Oh, I do need to know how thick that is, though. Whoops. Where'd that page go? It's in here somewhere. Just had it. Okay, square width O, square depth P, quarter 20. So we're basically at a quarter. I will undersize it, but I'll do a cut from the inwards, or from inwards out, so that I can get some nice clean draft on it. And square depth, I'm gonna do like probably 140, which means this also has to be deeper. Or there has to be a washer back here. $219. It's like 21875 probably. Hang on. 21875 times 64. Oops. 32. 730 seconds. That's fine. That gives me enough meat, I think. Extruded cut. Center. If you mouse over the circle first, it'll give you a nice, here, let me show that again. So, center rectangle, so I'm defining the center first. And if you mouse over the edge of the circle first, when you mouse it in the middle, it'll let you go directly to the center point, which is super handy. Oops, hang on. And now I've selected the face and I don't need it. And if you pick inside a polygon that's has regular sides, Alt-Q, you pick all the sides in there, and then Alt-Q makes them all equal. So you can draw a rectangle and then have it be immediately square. So let's do I think it's 250 seems fine. Exit sketch. And then we're going to offset into the part by desired depth, 140. We will have the plate out here, so that's going to be more than 10 thou thick. Actually, let's just do 125. That seems nice and round. So offset starting into the part, up to next. And we're going to draft outwards by, say, 5 degrees. And now we have an interface for a carriage bolt that I'm going to ruin with fillets. Well, chamfers first. Well, I don't know. Fillets, 0.4 millimeters. I'm just going to do it by millimeters since that's easier. Ooh, I should be able to just pick internal to feature and it'll grab all of them at once. And it does. Hooray. I am going to go 260 though, since this is a square cut, or this is a square feature that'll be receiving torque, so it should be okay, I think, to hang on, let's drop that draft a little too, maybe 3 degrees. Whoops, something broke. That was weird. Something broke and it just didn't want to rebuild. But yeah, there's a carriage bolt pocket. Sweet. And now we don't have to change any of the fasteners. And this is going to be only a little bit thicker than the original one. Could probably even thin this part back down a little bit, probably. Say 0.2. And then our depth is 0.075, which is what the original part is, or what I measured originally. This is only 0.75 apart, so we maintain our expected depth from the bottom of the carriage, or from the bottom of the square to the base of the nut. And we also get a free retaining feature, which means we can get rid of that washer, which means things should be a little bit more collected. Yeah, I'm pretty happy with that. I'm going to add that chamfer. Is that going to be too big? Maybe a little bit. I'll stick to 20 thou. Let's see that. 0.02 inches. 0.02 inches millimeters. Yeah, 0.5 millimeters. Yeah. All right. Okay, so, how far into this are we? Okay, 45 minutes. That's not too bad. Yeah, I don't really have anything to add to this because I've got all the features. I've got extra slots for drilling more holes if we need them. I've got the original 2 holes. We've still got the sliding feature. This bit is way stiffer now. Yeah. I don't think this part needs anything else. I think you could probably just print them as is. You will have to drill holes for additional fasteners if you want to buy them. If not, then this part will still work, but I imagine it would probably help to have the extra fasteners. Somebody's messaging me. Come on, load. Okay, nothing important, fortunately. Yeah, I think this part's good to go. So, I don't have anything else to add. I'm probably just going to kill the stream here since this part is all good to go and I can ship it off. Or, fingers crossed it's good to go. We'll see how the first print works. If you have any additional questions and you're watching this down the line and didn't get to participate in the live stream, that's fine. Feel free to ask questions in the comments. I'm always happy to this one probably won't get up on Thingiverse just because it's it's a very specific design and I don't think anyone's really gonna need it. So, oh well. Yeah. Yeah. That's all I've got. Thanks for coming and watching. Boink.